8.2 WSP. I'm going to be explaining most of the even ones, not all, but let's take a look at number 2. We want to find that LCM, and how do we do that? We factor the terms and we jot down what's in common, and then we bring down everything else. So in this first one, I have an a squared. Let me do it in red actually. A times A, and then a b to the third, b times b times b, and then a c at the very end. This is the factored form of this. Let's factor this guy out. And I'm going to do this one in blue. It's really a times b times c times c times c times c. There's 4 c's right there. So what we do is we jot down what's in common. There's an a there, so I bring that down. There's also a b in common and a b in common, bring that down. And there's also a c in common and a c in common, bring that down. But in addition to that, we need to bring down everything else, okay? So what is everything else? We have another a right here, another 2 b's, another a, another 2 b's. We also have 3 c's right here, 1, 2, 3. And if we multiply all this through, we will get our LCM. So let's begin with the a's. A times a, that's a squared. B times b times b, b times b times b, that's b to the third. And then we have our c times c times c times c, that is c to the fourth. So a squared, b to the third, c to the fourth is your LCM for number 2. So on number 6 here, we have a regular 3, and then the next item is a binomial 4w plus 2, and you could actually factor something out of there. You could factor out a 2, and what would you have left? A 2w plus 1. And this last one is actually a difference of 2 squares, which means we could factor a difference of 2 squares by square rooting that first perfect square term, square rooting the second perfect square term, plugging it into our answer format. So the square root of 4w squared is 2w, and the square root of 1 is 1. And of course, because it's a binomial, not a trinomial, the middle term has to cancel out. So 1 has to be a plus, 1 has to be a minus. So this is what we have here, guys. We have the number 3, we have 2 times that binomial, and then that binomial times that binomial. And again, you're supposed to write down whatever pairs up. So what actually paired up here? The 2w plus 1 paired up with the 2w plus 1. So our LCM is going to have that 2w plus 1 written one time because they paired up right at one time. Does anything else pair up? Do you have a 3, a 2, a 2w minus 1? Nothing else pairs up. So you need to bring down everything else. I'm going to bring down the 2w minus 1, put it right here. 2w minus 1. And I'm also going to take this 3 times 2 and put it out here in the front as 6. Ladies and gentlemen, that is your LCM for number 6. Let's do another, let's go an easier type question. Number 8. I guess I'm doing all these for you. No, I'm not. You could do number 4. So number 8. We have a quadratic trinomial. Again, factor everything possible. That way you could write down whatever pairs up and then bring down everything else. So this first quadratic trinomial of x squared minus x minus 6, you could rewrite that. You know what, I probably shouldn't put the line there to look like a fraction. You could factor that by thinking what times what is your c value that if you combine together is your b value. What times what is negative 6 that if you combine together is negative 1. It's going to be a negative 3 times a positive 2. That's factored right there. Now let's factor the other one, x squared plus 6x plus 8. Put an x right here and an x right there. Think what times what is a c value? 8, that if you combine together is the b value, 6. What times what is 8? That combines together to give you 6. That'd be a positive 4 times a positive 2. So we have our factored form of the first item, our factored form of the second item. Does anything pair up? Yes. We have the x plus 2 and the x plus 2. So our LCM is going to have that x plus 2 written one time. Whatever pairs up, you write it one time. What about everything else? You bring it down. And as you could see, that's what I did. I took the x minus 3, the x plus 4. There's my LCM. Let's jump to something more fun. Down here where we're actually adding and subtracting fractions. All right, number 10. Well, you want a common denominator, and to find that LCD, what you would need to do is factor each of them and write down what's in common, or not what's in common, what pairs up one time, and write down everything else to get that LCD. All right, so this first one, 6AB, that's really a 2 times 3 times A times B. That's a completely factored form of 6AB. Let's factor the 8A. Well, 8A really becomes 2 times 2 times 2 times A. Okay, so let's see what paired up here. We have a 2 and a 2. We write that one time, that paired up once. What else paired up? Well, we have an A and an A, so we're going to write that A one time. And everything else that did not pair up, you just rewrite it. Now, you're probably thinking, oh, these 2's paired up. No, they didn't, because both of these 2's are in the same denominator. It'd have to pair up like 1, 2 right here and 1, 2 over there, but we don't have another 2, all right? So what's left over here, we have a 3 times 2 times 2 with a B, okay? So we could write that down, 3 times 2 times 2 with a B. So what is our LCD going to be? It's 2 times 3, which is 6. It's A, and it's 2 times 2, which is 4. And it's also another B right there. So 4 times 6 is 24AB. So that's your LCD. So you would write 24AB underneath those fractions as the common denominator. And then you would think, what do you do to this first denominator to get this common denominator? 6 times what gets you 24? 6 times 6 times 4 gives you 24. Okay, and what else do we need? You already have an AB here, you already have an AB here, so it's just that multiplication of 4 that you need to get that 24AB. So go ahead and multiply by 4 up here. So you end up with 20 on the numerator of the first fraction. Now, this other one, 8A to become a 24AB, well, from the 8 to become a 24, you're definitely going to need to multiply it by 3. The A is already there, so you don't have to multiply it by another A. It's just 3. But obviously, this is missing a B, so you need to multiply it also by a B. And whatever you do to the bottom, you must do to the top. So we're going to multiply the top also by that same exact 3B value, giving us a 21B up here. Now that we have a common denominator of 24AB, we could now actually subtract 20, take away 21B. Now, the thing is, you can't really subtract that. You just rewrite it. 20, take away 21B. And there's your final answer. If you were taking a multiple choice test, they may switch negative 21B to be in front and then plus 20 to be second. But I believe that's the answer that they have on the worksheet. A lot of people get freaked out when they see adding and subtraction with fractions and regular terms. Remember, you can make anything look like a fraction. You could put the 2x over a 1, you could put the 5 over a 1, and you could combine all these fractions. In order to add or subtract them, you need a common denominator. So obviously, you're going to have to change all of these 1's to become the binomial x plus 4. This will be your LCD. Okay. So the first fraction, let's convert that to an x plus 4. The second fraction, let's convert that to an x plus 4. And the third fraction is already an x plus 4. So I'm not going to do anything to that third fraction because it already has a common denominator, x plus 4, so I'm not going to mess with the numerator. There it is. How do I change the 1 to become an x plus 4? Well, you'd have to obviously multiply it by x plus 4. And whatever you do to the bottom, you must do to the top, x plus 4. So you're going to have to take this 2x and distribute it to both terms. 2x times x is 2x squared. 2x times 4 is 8x. And how are you going to change this 1 right here to become an x plus 4? You're also going to multiply it by x plus 4. So you're going to have to multiply this top one by x plus 4, which means you're going to have to distribute the 5 times x, giving you a 5x, and the 5 times 4, giving you a 20. So we have modified the first two terms to become fractions with that common denominator of x plus 4. I am now ready to add or subtract the numerators. in this case, subtract both numerators. So we need to understand something. It's not a single term, it's a binomial. So you have something minus this binomial, which means that when you say minus this binomial, you really need to distribute the minus sign, make it become a negative 5x, and make it become a negative 20, okay? So here's my new numerator, negative 5x minus 20. Same thing over here, we have a minus sign, distribute it to both terms. If you distribute it to both terms, you're gonna end up with a negative x and a positive 8, okay? So since I've already distributed them, I could change them to plus signs because I've already distributed the minus. They're no longer minus signs right there. So now we could actually get our answer over that common denominator x plus 4. So let's begin by combining like terms with the biggest ones first with the highest exponent, 2x squared. There's nothing else to combine it with. Write it down, 2x squared. Then we have x's. Let's combine the, let me do it with a squiggly line, 8x. Let's combine that with a minus 5x. That'll give us 3x. And then 3x, take away another x, is 2x. So positive 2x. And last but not least, the numbers. We have this negative 20 that we're going to combine with this positive 8. That'll give us a negative 12. So there's our answer. You are supposed to try to continue to factor and see if you could cancel anything out. Let's just see what happens, all right? I do notice that I have the multiple of 2 and all 3 terms on that quadratic trinomial in the numerator, which would mean I could pull out the GCF of 2, having x squared plus 1x minus 6 left over on the inside. Now this is still over the x plus 4. Now on the inside of the parentheses, I do have a quadratic trinomial, x squared plus 1x minus 6. So what I'm thinking is maybe I could rewrite that quadratic trinomial as 2 binomials being multiplied together. All I do is think what times what is negative 6, that if I combine together is positive 1, and it will work. I'll have a positive 3 times a negative 2. So that's my completely factored form of this top one, and it's still over the x plus 4. Now, unfortunately, nothing cancels. It would have been nice if this would have been an x plus 4 so I could cancel it further, simplify it further. So this is our answer right here. Since nothing canceled, maybe they list the answer as this one. Since they know that nothing cancels, maybe they don't even bother factoring because nothing cancels. But either one is perfectly acceptable. But then again, the only way you'll know if you could actually cancel anything out is by factoring. So this is the definite better answer because you have to factor in order to see if you need to keep canceling. So I would actually not say that this is the final answer. This one is the final answer, even though both are correct. Let's move on. Let's jump to number 18. Again, factor everything first. That way you could get your LCD by writing down whatever pairs up and then bringing down everything else. So let's factor this first quadratic trinomial, put a y and a y. What times what is negative 10 that if you combine together is negative 3? Well, that'd be a negative 5 times a positive 2. Negative 5 times 2 is negative 10. If you combine it together, it does give you a negative 3. So that's our first denominator. If you want, you could put a line right through it. You don't have to, but I like to since I just rewrote it. I don't want to look at this anymore. This is my new denominator. This guy over here, we're going to do the same thing. Let's put the y right here, the y right there, and let's think what times what is negative 2 that if you add together is positive 1. Well, that'll be a positive 2 times a negative 1. So I've factored both. Now to get our LCD, let me make some space here, to get our least common denominator, we take down whatever pairs up, right, and write it once. We have a binomial y plus 2 and y plus 2. Write it down, y plus 2. What else? Well, there's also a y minus 5 and also a y minus 1. So we need to write that. Y minus 5 and y minus 1. Okay, so that's our LCD. So we're going to rewrite both fractions with that LCD. We're going to have the... And now we need to ask ourselves, how do we get from this original, well not original, this factored form denominator to this new one? We have a y minus 5 times y plus 2, and it's missing the multiplication of the binomial y minus 1. So we are going to have to multiply both top and bottom by y minus 1. So y minus 1. Now keep in mind that this numerator is a binomial y minus 5. So we are going to have to do quite a bit of math right here when I multiply. But before doing that, let me just jump over here. What do I need to do to this binomial, or this denominator, y plus 2 times y minus 1, to get a y plus 2 times y minus 1 times y minus 5? We'd have to multiply also by that y minus 5, both top and bottom. Okay, so let's first figure out this numerator by doing this math. Let me zoom in here. It is multi-step, right? Y times y, y squared. Y times negative 5, negative 5y. Negative 1 times y, that's a negative 1y. Negative 1 times negative 5 is a positive 5. Of course, combine these middle terms, you will have y squared minus 6y plus 5. Let me write that down as my numerator for this first fraction. Y squared minus 6y plus 5. Now let's do the math over here also. Y times y, that's y squared. Y times negative 5 is negative 5y. And that's going to be the numerator of our second fraction. Y squared minus 5y. Okay, what else? Now that we have a common denominator, we're going to be able to add the numerator with the numerator, which is just combining like terms. So our answer will obviously be over that common denominator. And let's begin to add these up. We have the y squared plus y squared. That's 2 of those y squares. And then we move on to the y's. We have a negative 6y combined with a negative 5y. That's going to give us a negative 11y. And last but not least, we have this regular constant value of 5, so put plus 5 at the very end. This is our answer, unless we were to be able to factor this. That's a tricky one. Now, why is it a tricky one? Because the a value is not 1, right? Like if I didn't have a 2 right there, then I could think, oh, what times what is 5 that if I combine together is negative 11, and there is no value, so I would say, no, it's not factorable, that's it. That's our answer. However, since we do have the a value of 2, we should attempt that longer process of factoring. I hope we remember, step 1 is to multiply a times c. So we really have 2 times 5, which is 10, right? A is 2, c is 5, 2 times 5 is 10. And then the second step is to think of the multiples of 10 that combine together to give you the middle value, which happens to be negative 11. So how could I get 10? Well, it's either 1 times 10 or 2 times 5. And if I look at 1 and 10, when I add these together, it does give me 11, but I want a negative 11. So that means I have the right numbers, I just have the wrong sign, right? So I need to change both of these to become a negative 1 times a negative 10. Step 3 is to write it in your factored form format with your ax right here and your ax right here. So in this case, our a value is 2, and we don't have an x, we actually have a y. So that's going to be a 2y right here and a 2y right there. And the pair of numbers from step 2 simply plugged in right here and here. So we're going to put a minus 1 and a minus 10. Step 4 is to magically reduce both binomials by whatever possible. And as you could see, the first one, 2y minus 1, you can't reduce that by anything. You can't factor out anything. The other one, actually I shouldn't use the word factor. We're magically reducing, magically dividing, right? Why magically? Because you don't actually factor out the value of 2. You're just dividing by 2, and you're going to get y minus 5. So we have factored the above quadratic trinomial that had the a value of 2. So this is the factored form of it. Let me rewrite this whole answer, but instead of this quadratic trinomial, let me write the factored form of it. So let me make a little more space. Let me write it right here. Well, I'm sorry, right here. So there's my denominator. Let me write down this factored form over here. We have the 2y minus 1 in parentheses, and we also have a y minus 5 in parentheses. And as you could see, the binomial y minus 5 above will cancel out with the binomial y minus 5 below, which means that our final answer for this guy will be 2y minus 1 over y plus 2 y minus 1. So looking at the second page here, let's do number 22. Okay, so when we look at all three denominators, we have the a minus 3, a plus 3, and a squared minus 9. Can't factor that, can't factor that. This you could factor, so let's rewrite this guy as the difference of two squares, which would be a with a 3, a with a 3, of course 1 plus, 1 minus. So what we're going to do is identify the LCD, and to find the LCD you take what pairs up. And what pairs up? There's an a minus 3 here and an a minus 3 there. So there is an a minus 3 as the first part of your LCD. What else pairs up? Well, the a plus 3 and the a plus 3, that also pairs up. So you write that one time, a plus 3. And if there were anything else, like if there were a times 5, or if there was like a plus 1, then you would also add that on there. But of course we took this, what paired up, put it right there, took this, that paired up, put it right there. This is our LCD right here. So these three fractions, that has a minus sign and a plus sign right there, these three fractions are going to be rewritten with the new common denominator, which will be the binomial a minus 3 times a plus 3. So I'm going to do my three fractions right here, the first one minus the second one plus the third one. Okay, let me put that common denominator on all three of those. Please feel free to pause it so you could actually write all this down on your paper. But anyway, what do we do to this first binomial to get this binomial times that a plus 3? Well, obviously it's missing the a plus 3, so let's multiply this first one by a plus 3, and whatever you do to the bottom you must do to the top, multiply by a plus 3. And of course you're going to distribute 2a times a, that's 2a squared, and then 2a times 3, it's positive 6a. Okay, so now right here from the binomial a plus 3, how do we get a plus 3 times a minus 3? Well, obviously it's missing this times a minus 3. So let's put the times a minus 3 right there, and also multiply by a minus 3 up here. What you do to the bottom, you do to the top of every fraction. And of course we are distributing. So when we distribute 2a times a, that's 2a squared. 2a times negative 3, that's negative 6a. And last but not least, what do we do to this denominator after we factored it? What do we do to this denominator to get this new LCD? Nothing. This is the LCD. So we're not going to do anything to that denominator, or that numerator. 36 is still going to stay 36. So now that we have a common denominator on all three fractions, which was the LCD that we found, we can now combine the numerators. So we could take this binomial and then combine it with this binomial. But remember, this minus sign would imply that you need to distribute that minus sign into both terms. Okay, so up on top what we really have is a negative 2a squared and a plus 6a. That's after we distribute that minus sign. This positive 2a squared becomes negative 2a squared. This negative 6a becomes positive 6a. And now we're able to combine the first 2a squared with this negative 2a squared, and what happens there? They cancel out. And then we could combine this positive 6a with this positive 6a, which means we have a positive 12a so far up on the top. And it is going to be over that common denominator, a minus 3 times a plus 3. Okay, so we've combined these two fractions. There's my answer. Let's bring this one down. And now that we have that common denominator on both of those, we could simply combine the top with the top. So you can't really combine 12a plus 36. You're just going to rewrite it. So let's do that. Let me make some space here. Over here, we have equals the common denominator on the bottom with the 12a plus 36 up on top. Now, some of us are thinking we're done. However, remember, whenever you have a fraction as an answer, you're supposed to try to reduce it. What does reduce really mean? It means factor it so you could get multiplication, so you could get things to cancel. So I don't know if we're actually going to be able to reduce this, but we can look at this numerator and recognize that there's a common multiple of 12. You could factor out a 12. Okay, so let's do that. Up on top, we have equals, and up on top, if we pull out a 12, what would we have left? Well, 12 times what gets us 12a? That'll be an a. And then 12 times what gets us a 36? That'll be a positive 3. So the numerator, 12a plus 36, becomes 12 times parentheses a plus 3. And it is over that common denominator that we found, a minus 3 times a plus 3. So we factored that 12 out, and now we see that we have a binomial a plus 3 and that binomial a plus 3, which can eliminate, leaving us our final answer 12 over a minus 3. That is our answer for that problem. Yes, it's a lot of work. I hope you guys could get this. Of course, if you need help, just call me, right? We also have these complex rational expressions. Why are they complex? Because we have fractions within the numerator, within the fraction, right? We have a fraction as a denominator of this other fraction, a fraction within a fraction. Those are complex. I am going to, I guess we'll do 24 since you're supposed to do 24. I'll do it for you here. Hopefully you could follow along and understand it. So what we're going to do is we're going to cover up the denominator and just focus in on the numerator. Okay, we're going to actually find a common denominator so I could actually subtract these two fractions. So we're going to treat this like if it were a problem. Okay, so here's r plus 2. We need a common denominator, and the common denominator will be multiplying those two together. Okay, so let's put the fraction, minus sign. Common denominator will be this r times the binomial r plus 2. So here it is, r times r plus 2. And I write that twice, r times r plus 2. Then we ask ourselves, how do I get from this r to become a r times r plus 2? Well, it's obviously missing the r plus 2. Okay, but what you do to the bottom, you must do to the top. So you're going to have to multiply the top by r plus 2. This is where it gets a little fun, because you have a binomial up on top times another binomial. So you're going to have to distribute and combine like terms. So we have r times r, which is r squared. We have r times 6, which is 6r. And then we have 2 times r, which is another 2r. And we have 2 times 6, which is 12. And when we combine like terms, we combine these middle terms and we'll get 8r. So on the numerator of the first fraction up here, we have r squared plus 8r plus 12. Okay? Now let's look at the second fraction. And how do we get from a r plus 2 to an r plus 2 times r? Well, it's obviously missing the multiplication of r. So let's put that multiplication of r right there. And what I do to the bottom of a fraction, I must do to the top of a fraction. So my second fraction will have r times 1, which is r, right there in the numerator. Now that we have a common denominator, r times r plus 2, r times r plus 2, I could actually subtract this numerator with this numerator. And that's just combining like terms. So our answer up on top, remember we haven't even looked at that one yet. Our answer up on top will be the fraction, of course, going to have the common denominator underneath it, r times r plus 2. And up on top, when I combine the, well, r squared, you can't combine it with anything, just bring it down. But I could combine this 8r with that minus r. 8r minus r is 7r, positive 7r, and bring down that 12. So there's our answer for the numerator, okay? Let's now look at the denominator. And we don't have to add or subtract any fractions here, but we do have a quadratic trinomial up on top and a quadratic binomial on the bottom. How about this? To not get confused, I already subtracted these two fractions and got this answer. So what I really have is this answer up here divided by this fraction. So how do we handle rational expressions? We, instead of writing it vertically, we write it horizontally. So let's write this first fraction. Again, you're probably going to have to pause this to catch up. So I just rewrote that one over here, which is the top one. Now I'm going to put the division sign. So I am going to put the division sign, and then I'm going to, well, for me it's really easy. I could actually just cut and then bring that down right there. So here is what I have. Instead of the top one divided by the bottom one, I wrote it like this: the top one divided by the bottom one. And then after that, I am going to flip the second fraction to rewrite this as multiplication. Okay. And even before doing that, I could go through and factor anything possible. So this first fraction, the denominator is already factored. That's great. So let me just rewrite it. We have a r times r plus 2. And up here on the top one, r squared plus 7r plus 12. Since the a value is 1, maybe, just maybe, I could think what times what is 12 that if I combine together is 7. And you will see that it is 3 times 4. That gives you 12, and if you combine them together, it does give you 7. So as I am rewriting it, I am factoring it. We know that this second fraction, the division, has to become multiplication, but I do need to switch the numerator with the denominator. So up on top, I should have this r squared plus 2r, but I might as well pull out the r that's in both of them. Okay, so I'm going to write this one up here. It's going to go up. I'm going to write it up here in the numerator, and I am going to pull out the r, and I will have an r plus 2 left over on the inside of the parentheses. Now this quadratic trinomial, I'm going to write it down here, but I'm going to factor by thinking what times what is 3 that if I combine together is 4. So I will have the r right there, the r right there. And what times what is 3 that if I combine together is 4? That would be a positive 3 times a positive 1. 3 times 1 is 3, and 3 plus 1 is 4. So now I've changed the division to multiplication. I've factored everything. Now that I have pure multiplication, I could cancel anything that I see alike on top with the bottom. As you can see, there's a r plus 3 up on the top left. There's also a r plus 3 on the bottom right. There's also an r plus 2 on the bottom left with the r plus 2 on the top right. And that is about it. So my answer is whatever's left over. I have a r right here and a r plus 4. Let me write the r first. R times r plus 4. And in the denominator, we have r times r plus 1. R times r plus 1. And guess what? I do have r being multiplied by that binomial, and then on the bottom one, r times that binomial. So because we have multiplication, I could also cancel this above r with that below r. And there is our final answer, r plus 4 over r plus 1. That is your answer for number 24. That's a lot of work. I hope you guys understood it. And again, guys, this work that you're doing, if you're cheating, if you're just writing down answers, or if you're getting the work from somebody else, it's not going to help you. You need this math, this knowledge to move on to the next math class, pre-calculus or stats. You need it. Okay, so please do your best in learning all this.